Yes, I'm back again. What we are going to deal with now is a process called photorespiration. We have just dealt with the Calvin cycle, which is the process through which carbon dioxide from the atmosphere gets into the leaves of the plants, gets fixed to form carbohydrates. I will just go back to the previous slide. Here, you will see that here the CO2 from the atmosphere combines with RBP, resulting in the formations of two PGA molecules. One carbon dioxide combines with a 5-carbon RBP molecule to form two 3-carbon PGA molecules. This is the starting point of the process of photosynthesis, and it is catalyzed by the enzyme called RUBP carboxylase enzyme. Now, plants that fix carbon dioxide directly through the Calvin cycle when it comes from the atmosphere are called C3 plants. But there is always a process of photorespiration that is associated with the Calvin cycle. The issue here is the enzyme RBP carboxylase can sometimes allow oxygen to be the one that is combined with RBP instead of carbon dioxide. So this enzyme RBP carboxylase cannot discriminate between carbon dioxide and oxygen. And remember, when the stomata of the leaf of a plant open, it is not strictly only CO2 that enters into the leaf. It is air, and in the air there is carbon dioxide, there is oxygen, and there are other gases. And if in the air there is more oxygen, then the enzyme will allow oxygen to attach to RBP. And when that happens, when it is oxygen that is being attached to RBP, you have got photorespiration taking place, not photosynthesis. But when you have got carbon dioxide being the one that is attached to RBP, then you have got the process of photosynthesis taking place. And unfortunately, both photosynthesis and photorespiration are processes that are catalyzed by the same enzyme. So when it allows carbon dioxide to be added to RBP, that enzyme is said to be carboxylating. It becomes RBP carboxylase. But when the same enzyme allows RBP to be attached to oxygen instead of carbon dioxide, that enzyme is said to be oxygenase enzyme. So it becomes RBP oxygenase. And when that happens, the process of photosynthesis of photorespiration starts to take place. And every time photorespiration is taking place, photosynthesis is not, because carbon dioxide and oxygen compete for their attachment on RBP. So this slide is not very clear, but you can see what the slide is actually indicating here. That's RBP. So basically when it reacts with carbon dioxide, it gives you two PGA molecules, 2-phosphoglycerate. You can see that. But when it is oxygen that combines with RBP, you can see this an oxygenase activity that result in the formation of 1-phosphoglycerate, 1 PGA, and 1-phosphoglycolate. Instead of 2 PGAs, there's only 1 PGA that is formed when photorespiration takes place. So photorespiration is a process that takes place in 3 organelles. It starts within the chloroplast. Part of it takes place within the mitochondrion, and then lastly also a body called peroxisome is involved in this process. Now, here it's what happens in the process of photorespiration step by step. You've got oxygen interacting with RUBP, and that will result in the formation of a phosphoglycerate and 1 PGA. 1 PGA and 1 phosphoglycolate. And that glycolate, this is taking place within the chloroplast. That glycolate is basically what we're interested in now. The phosphoglycolate is going to lose its phosphate group and becomes a glycolate, as you can see here. Then the next step is going to be the delivery of this glycolate from the chloroplast into the peroxisome. You can see the glycolate moving into the peroxisome. There is our glycolate there coming from there. In the peroxisome, that glycolate will interact with oxygen. There are enzymes involved in each and every step. So that glycolate will interact with oxygen, resulting in the release of a hydrogen peroxide, and that glycolate will be then converted into an organic acid called glyoxylate. Glycolate is also an organic acid. It's going to be converted into a glyoxylate. There's an enzyme that catalyzes this reaction of oxygen interacting with glycolate, giving hydrogen peroxide as a byproduct and giving glyoxylate as a product. Now, the next step will involve this glyoxylate which is an organic acid. It's going to be aminated. It is going to get an NH2 group from a glutamic acid, I mean to say. So when the glutamic acid donates its amino group, the NH2, to this organic acid is converted into an amino acid called glycine. In the typical transaminase process that we have dealt with when we were dealing with the assimilation of ammonium in the past part clips. So there is glycine. 2 molecules of glycine will be delivered into the mitochondrion, which is the final organ that plays a role in photorespiration. And inside there, 2 glycine molecules will interact with each other. You can see there, one glycine interacting with another glycine. One of the enzymes involved in that process is an enzyme called glycine decarboxylate. But the long and short of it is, in that process, you are going to have an ammonia being released as a byproduct. You are also going to have carbon dioxide being released as a byproduct, and the formation of serine, which is still an amino acid. Serine will be transported back to the peroxisome, undergo further processing, and so on and so on. But the most important point here is, here you have got the release of carbon dioxide, which is taking place within the mitochondrion. The starting point was the consumption of oxygen. You can see oxygen interacting with RBP, being assisted by the RBP oxygenase enzyme. That's the starting point within the chloroplast. And these organic acids that are formed there, delivered to the peroxisome, converted into amino acid, the amino acid delivered into the mitochondrion, the two amino acids, the two glycine interacting, forming one serine, which is an amino acid, but as part of the byproducts, what is released is CO2 and an ammonia gas. You can see you started with the consumption of oxygen and at the end the release of carbon dioxide. So this is the same thing that happens in respiration, but this time around, that is why this is called photorespiration, the use of oxygen in the presence of light. But we can talk about differences between photorespiration and respiration some other time. So, but basically that is why this process is called photorespiration. So, what is very critical is for you to understand step by step what happens from the time the oxygen attaches itself to RBP all the way until carbon dioxide is released in the mitochondria. Each and every step that takes place and each and every enzyme that is involved in each and every step that takes place. That is in brief what the process of photorespiration is. Thank you.